So we are pretty excited, and what we are going to share with you guys today is something that we are currently building in AirAsia, and like what we want to focus today is mostly what we are trying to build, why we are trying to build it, and how Istio is coming into the picture, right? So I think like the first thing that we really want to focus is that when you have a big company where you have so many different teams who are working together for different products, you have so many lines of business, and over the period of time you have different products growing in, and to support and serve them you have different gateway solutions that's like spawning over the period of time, right? At that point, the first major problem that you start getting is how do I really consolidate the practice? How can I start introducing some standard procedure and everything? And if you have a legacy team and legacy systems, it becomes quite a difficult thing, right? And that's where we're gonna start today, to be very honest. So today we are here with you, Ferdous, as Asia was saying. He's a software engineer, and we're working in the same team. We represent the AirAsia SRE team, and I'm a senior engineering manager. Apart from SRE, I handle few other segments of AirAsia, but SRE is one of the core segments that I take care of. Okay, so that's pretty much like who we are. Let's start a bit about understanding like what AirAsia does and what kind of a scale that we handle today, right? Those of you who know about AirAsia, it started. AirAsia started their business as an airline provider, and it's a low-cost airline provider for the Southeast Asia. And it has operations in Malaysia, Singapore, Indonesia, Thailand, you name it, all the Southeast Asian region. And like it's also expanded into some certain regions with other partnerships. And it's a huge network of, I would say, airline providing network. And for that, we used to have a system for, of course, for you to book your flights, and then hotels, and then activities, so many different other things. That was the pre-pandemic situation for AirAsia. Once the pandemic came in, we started pivoting a lot. We started thinking about what other different things that AirAsia can do with the current infrastructure that we have. And by infrastructure, I mean like the maintenance, like the operational infrastructure that we have, and also the people we have and expertise that we have in. What else we can do? And that's when we started pivoting into super app. And we can probably say now that these days in the Southeast Asia region, we started quite recently, to be very honest, but we started providing a lot of different segments of support. So one segment is travels, under which you have airline, hotels, Snap, and so many other things. And then we have e-commerce segment where we have fresh food, health, and like beauty, different types of product segments. And then we have very soon we are gonna bring in ride e-hailing business in Malaysia. And then we have, some of you might have known actually from the press release that we had very recently, that we actually acquired the business from Gojek in Thailand. So we are going to expand our food business there as well. So which means I'm just trying to give you an idea, like we are expanding in different verticals and different ways and lines of businesses. So it's quite a challenging environment, right? So just to give you an idea of like the few of the numbers that we wanted to share. For example, today so there are two numbers that you can see in the screen, right? The number on the right side of yours are the numbers that we had before the pandemic. It was almost 3 million users per day, and almost 2 million search per every day. And during any sell event, we would have like around 20 to 30K booking done within an hour, or in some crazy events, we had like, 50K bookings done, orders done within an hour of time. That was a pre-pandemic situation, but it's quite great to see that even during the pandemic situation, we kind of had almost a consistent, I would say, users visiting our site, almost 650K users visiting the sites, the different products that we have. Our base page, AirAsia.com, is being visited by almost 650K users, and then like almost 600 people are doing different types of search. I mean, they're either searching for flights, hotels, and lots of other things. Like, as I said, that there are e-commerce segments and other things. And then just to give you an idea of like how much, what kind of infrastructure that we are handling today as an SRE team, right? We almost have around 400 GCP projects, and in which our GCP projects are consisting of different types of course, like the infrastructures are different. We used to have just a year and a half back, I would say, the beginning of 2020, around that time, we used to have most of our setup in VMs and in GAE. That was the norm at that point of time, and that's exactly the time I remember. I just joined maybe like 3-4 months back, so I had the opportunity to see it from very closely, that how we started adopting GKE everywhere, Kubernetes, and that's where a lot of, I would say, a lot of our like modernized journey began, like in terms of infrastructure, how we wanted to architect our entire ecosystem. And since then, it's just 1.5 years, but you can see how aggressive we have been. Right now, we are standing in a moment like where we have almost 92% of our projects which are already migrated to GKE. Only around 8 to 9% of the projects which are still in GAE, GC, and GCS. We are still working day and night to onboard them as well eventually, right? And just to give an idea, like today we are running almost 500 GKE clusters, give and take, and it's huge. And out of which, almost, I would say, 12 to 15% of the systems are having Istio there. So just this is to give you an idea like that for how long we have been using Istio in our entire ecosystem, even though it's not adopted that much yet, because we have so many other legacy gateway solutions, like so many different gateway solutions, and over the period of time, people adopted to a lot of others as well, like Nginx controller, like Kong, and so many others, right? And those are still there, but if you see like how Istio has made the penetration in that entire ecosystem, it's pretty huge, like almost, as I said, almost 12 to 15% of it. Okay, so that's some numbers to give you guys an idea of like what we are dealing with today, and just to give a bit of idea about like why it's a lot, because the SRE team is not quite big. It's like a very minimal number of people in the SRE team that we have today, but we are proud, and we have certain pride to say that the people that are working in the SRE, each and every one is quite competent, and like all of them are having solid experience in the cloud native frameworks and tools and stack. So that's why we were able to pull this off, and now we are moving to a different journey, which we want to discuss in this talk. So we have multiple chapters. I think the first one, as you can see, we have decided to go with some, a bit of like funny or like funky titles. So we have 6 chapters that we want to cover today. The first one is At Your Wit's End. And it's basically what we want to cover is the problem analysis from our side, like what problem that we actually started the problem space that we want to actually bring in front of you, so that you can understand what we are trying to talk about, and then what was our solution for that, right? So I want to like give a floor to, I have been talking a lot, so I just want to bring Ferdous in. And Ferdous, why don't you go ahead and tell us a bit about like what problem that we had with the standardization.
Thanks, Munim. You guys can hear me properly, right?
Yeah,
Hello?
we can.
Yeah, yes, Munim,
Oh.
we can hear you fine.
Okay. As Munim actually mentioned that, throughout the years, when we actually tried to adopt Kubernetes, a different team actually came to adopt Kubernetes at different point in time. The definition of standards were actually different in different point in time. So different team, due to this rapid, adoption of Kubernetes, different team actually tried to adopt the best practices that were available at that point in time. So now, after 1.5 years, what we have is almost a same or similar set of tools that actually solves almost identical problems. So now, since we have a very variety of different tools that actually solve the same problem, we kind of have to figure out a common group of features and know how to make it work in all those stacks. And since there is a variation of different tools, standardizing a common practice or an optimal practice or a secure practice becomes very, very difficult, because not all the tools necessarily support all the features. Let's say, for example, we are trying to introduce a certain feature. That feature is actually not available in the open source version of the tool, or that feature is not supported at all. So if you want to guide the different teams that, when you are actually trying to use this tool for a certain gateways or certain service mesh, certain load balancer ingress, it becomes really hard to standardize, because there are so many different things that is actually in adoption across the whole community, across the whole different dev teams. The second problem that we see is that, in AirAsia, the DevOps team is kind of like a centralized team. What happens is that individual SREs are actually assigned to different line of business and assigned to different dev teams. So when there is a troubleshooting issue, what happens is that you kind of have to jump into a certain ecosystem, and then on the fly, you have to learn what exact tool that they are using, and you have to learn how to upgrade that, and you have to learn how to fix that, and the knowledge is not necessarily transferable. Let's say, for example, you are working with a certain stack, a certain tool, you kind of, over the period of time, learn how to actually upgrade that, solve certain problem with that. And then if you actually switch to another troubleshooting issues, some days later, you completely see, you will see that completely different picture. So the knowledge is not necessarily transferable. And let's say, for example, if I actually talk about the control, since there is a lot of entry point in your whole ecosystem where traffic is actually flowing in, when you want to impose some control, some standardization, it becomes really hard to impose those rules and control, because there are so many different places that is traffic that traffic is actually penetrating your system, and the attack surface becomes exponentially bigger, and any control measurement that you want to take, it takes that much more effort. And when different teams are actually adopting different variation of tools, different version of tools. I remember for a certain API gateway, we actually had 3 different versions of the same tool that was actually adopted in 3 different point in time. So, upgrading that or managing the cost of that was actually really, troublesome, because we had to develop expertise in 3 different, it was almost like developing expertise in 3 different tools, because the version or the technical detail about the version of the same tool in different point in time was quite significantly different. And fine-tuning the resource and how we actually want to use a certain tool those actually come with experience. So unless you actually put a certain amount of time, you actually don't get to that granular level of understanding that how you actually can optimize the cost of a certain tool. Can we go to the next slide, Munim? So since the responsibility and the control was scattered in different number of teams, it was actually a recipe for disaster. And every now and then a certain system breaks. DevOps team or SRE team actually has to jump into the to the effort and sort of learn on the fly how to debug the system. What are the intricate details to actually that is needed to debug the system, and then take a decision based upon that. And any time the system is down, it's actually directly related to the business hours, and you actually lose the business. So this is actually an inherent complexity that is actually related to a large legacy system. So when you want to actually organize the effort,
I want to add a few things actually on top of what you said, Imran. I mean, just to give a few more perspectives of what Imran just explained. I'm sure like you guys have already grasped the idea of like what we are trying to tell here, but I just want to give a few more perspectives of it. Like, you see the problem that Imran explained, that standardization. When we are talking about this standardization, it's huge because of two things. One is number of ways of doing same thing, as Imran said already. Like if I have to bring in a gateway, so in most of the teams, they just need a gateway. Maybe they just need a, like, let's say we have multiple API gateways, right? And each of the API gateway is hosting different subset of APIs from different teams. So let's say I have a domain a.b.c. It's an API gateway, and maybe behind it it's a gateway, open source gateway that we are using, and it's pointing to different subset of APIs from different team. And the problem that happens over the period of time is that once they start using it, they get used to it, right? And consider and just multiply it by the number of teams that you can have, number of product teams that you have, number of teams who are actually creating these gateways for their systems or getting attached to different gateways. Then it becomes really problematic for you to come up with something and force a standardization. It's not easy. That penetration is very hard, right? There's a lot of frictions. Why I have to do that? Why I have to do this, right? That is right there. And if you have to bring in that standardization across, you have to come up with a very good strategy, right? You have to have a proper templates in place, or maybe a certain, like structure for people to follow, lots of documentations on board them. So that is right there, right? That problem is, one is technical and another one is people. People are not quite used to changes. I think like we already know about it, right? And to the control part of it, I just wanted to add one more thing on top of what Imran said. I think the major problem with control that we were looking at is that we will show you in the later part of the talk, is that our AirAsia.com is actually pointing to certain layers. And after that, there is a reverse proxy right behind that. And that reverse proxy is actually pointing to different, of course, the application, different product, upstreams. But what happens is, like, whenever certain portion is going down, everyone has some segregated tools for observing the failure and to take action against it. But it's not centralized. It's not centralized control. If a particular upstream is down, that team knows, but that information has to propagate it to everyone else. Hey, you know what? This particular X upstream is down, but that centralized observability was missing. We had all the data everywhere. It's coming in. We were not being able to put this together and stitch everything so that we get that visibility, right? And as a team, as a SRE team, we really needed that. That was missing right there. And just to add on top of cost part of it, is because since every team has different stack running in, somebody's running this, running that, everything is actually two different types of costs, right? One is infrastructural cost and another is the maintenance cost, development cost, right? Whatever you do is development cost. Whatever you do, operational cost, you can say as well. So that was there, and that's piling up, right? And that's piling up over the period of time. If I had just one single kind of technology right there for this particular problem, I wouldn't have that. I would knew that what exactly is the resource consumption that I have to go for, and I would have planned it accordingly. And that way I would have never ended up with over provisioning my resources for those purposes, right? But today, that's what is the case. We have over provisioned a lot of our those gateways and reverse proxies and systems, and it's very hard to control. Coming up with a standardized resource allocation plan for each of them, because each of the tools are different. Their resource consumption trend is different. Their resource consumption process is different. It's very hard. And that, of course, adds up to your cost, right? And I think this part Imran has beautifully covered and already told us about. So yeah, we just wanted to give you a very high overview of like the problem we were having as an SRE team. And the problem that we were looking at is it's not immediately visible to other people, other part of the organization, because they're not handling it. But we were receiving scattered complaint that, hey, you know what, we are using this, and today that this problem happens, we have to always either go to you or we have to fix it, blah, blah, blah. They are using this, why cannot we use that? So all of these questions were piling up, all of these complaints were coming up, right? So all of this together eventually made us think about something else, something that we really wanted to come up with. So that's what is about what we're going to discuss next, the solution thinking. Before going there, Imran, do you want to add anything on top of like what I just mentioned?
No, I think you covered.
Great. Yeah, Imran, but I think like the friends in the call, I think we can give them an idea about like how we have adopted while we are at it, before going to the solution, why we went for Istio. Maybe we can give them a brief idea about like before even proposing what solution we're going to do. You can basically, I hope, already know that we came up with something that depends on Istio, that's on top of Istio, right? So why did we go for it? What was our maturity with Istio like? What was our experience with Istio like, right? So you have been working with it from the very beginning. Why don't you go ahead and give us a brief about your experience on this, and why did we actually go for it?
So yeah, that would be an interesting discussion. So initially, before actually coming up with the proposed solution, we have been using Istio in different projects about a year now, and in several of the projects we have been using Istio as a service mesh, and there has been a lot of effort to buy in or getting the different development team used to the fact that these are the these are the features that actually Istio gives you, and wherever the use cases are, we try to use Istio in those segments to solve a particular set of problems. And in whichever project that we have used so far, Istio, it was actually successful. Let's say, for example, in some of the projects we have used Istio as a very for JWT authentication. In some of the projects, we have used it as a very basic ingress even. Well, after actually, and in some of the projects, one of the core features that we actually used was the canary deployment. And throughout different point in time when we actually used Istio, the development experience for the user experience as a developer and also as an SRE individual, it was quite good. The abstractions that you use to adopt Istio in your different projects, they are actually quite similar how you use Kubernetes in your project as well. The abstractions are actually quite similar. And also one of the core features that we actually chose Istio for is that it gives you a way to decentralize your configuration. In a lot of the open source tools that we have used so far, different ingresses and different API gateways, the common pattern is that all the configurations are actually centralized in one place. Since the configuration is actually in one single place, previously the control was actually in one single place as well. So even though the application details are actually with different dev teams, they know how their applications should be accessed. They know how their course policy actually works. They know which headers should be allowed and which headers should be exposed, and all those necessary details are actually with the developer itself. But when they needed to change anything in those configuration details, they had to come to the SRE team and actually ask for a change request. They actually asked for a certain change. SRE team will actually make those changes, and then the dev team has to test those things out. You can actually see there is a lot of back and forth communication between two different teams, one having the control but lacking the context, another one had the context but lacked the control to make their own changes. One of the benefits that Istio give, we will actually show you a pattern in a later point in this presentation, that if you actually give a certain development team their own virtual services, that they can actually define their own different paths, their course policy, their header requirements and everything, they are responsible for changing that. And the different development team, when they need access to a certain other applications which is actually managed by a completely different team, they can actually communicate among themselves. The SRE team doesn't have to intervene in the middle or control the communication in the middle. So this is way less communication, and the development team actually can actually focus on their development bit. So this is one of the primary selling point that actually led us to this idea that eventually, since the context is with different development team, if we can actually distribute the responsibility to different development team, then what would eventually happen is that gradually their development speed would actually increase because there is less overhead. So that was one of the primary motivation that actually gave birth to this idea.
Yeah, I think one important part actually add to on top of what you just said would be to put it together in like this, is that we in different parts of the team, different API gateways, different solutions that they were using, they had different features they needed, right? I think when we started mapping them together, the feature metrics, we found out that Istio is a complete solution for that. Whether I want to use it for the service mesh, whether I do not want to use it as a service mesh, I want to use it just as a gateway, and I want observability, I want this and that, I want to enable MTLS between my service to service communication, whatnot. It's literally out of the box right there for you. That's one of the core selling point, apart from the other selling point that Imran was mentioning. That actually is the relevant selling point of why we built HyperMesh. But why if we want to answer why we chose Istio in the first place, is actually that it's actually a bundle of whatever we were looking for. We did a very, I would say, rigorous feature mapping, like what we really want to go, where we really want to go, what are the things that we want to use from these and that. I have n number of teams, out of n number of teams, this team needs that, this team needs Y, Z, whatnot. How can I really map back to them to a single tool? How that will reduce the overhead, the technical overhead that we will have over the period of time. We don't have to know n number of things. I just can know one single particular technology, one single particular tech, and that will work for everyone, right? That was one of the things that we really found Istio as an ideal tool, to be very honest. The second one is like what Imran mentioned. I would like to give a bit more emphasis on that, since people are already, we have been using Kubernetes for 1.5 years. People are already used to the Kubernetes manifest. So it's actually much easier for us to onboard them with a similar configuration language, similar configuration pattern, abstractions. It's much easier. Whenever we're going to them, it's much, oh, I understand. Oh, there's a virtual service. There's this resource. I understand that. There's a resource. It's much easier to communicate with them in that language, in that way, in that thought process, and to really convince these people to onboard. That's also another selling point because of the easiness, because of the, already having a quite good penetration, which is like your mental model is already quite used to, right? Yeah, so these are a few core reasons why we chose Istio for whatever we are going to show you in next few slides. Cool. Okay, so today, let's start with, before even going into where we want to go, I think we already have discussed and explained the problem a bit. Not really sure if we were able to give you the pain of the problem that we were facing. And this diagram is here to show you what is the current structure today, current flow of data from different parts of the journey, right? Different infrastructural components. So as you can see, AirAsia.com is actually the base. AirAsia.com/food/fresh is the base of all the products that AirAsia has today as a super app. So that's basically pointing to a CDN. That DNS is pointing to a CDN, then a WAF, and then that WAF is pointing to a reverse proxy, and then that reverse proxy is pointing to all these application upstreams, right? All the, the product that we just mentioned. Same way we have API gateways. For example, let's say we have gateway 1, g1.apirasia.com, right? It's actually pointing to a WAF again, and that WAF is pointing to a gateway. What is the technology of that gateway is not the purpose of this discussion. Let's say it's some gateway. That gateway is pointing to a certain set of paths, different APIs from different teams. Some other API gateways there as well, g2.apirasia.com. For some reason, we have to maybe create another API gateway, and that is containing another subset of API upstream. Even though I'm showing you just 2 API gateways here, there are actually so many. And even though the base setup for AirAsia.com is with 1 reverse proxy, but multiply that with number of different environments you have, multiple different environments, you have different same setup, like same reverse proxy setup, but different configurations are there. So it's a nightmare, to be very honest, right? This setup is a nightmare. So our approach here is, first, how can I really get rid of, you see there are, if I start with an application path, it's 3 layers, right? CDN, WAF, reverse proxy. If I start with an API gateway, it's like WAF and then gateway. What is the exact point here that we can really replace with something else? And that something else can start pointing to applications as well as API paths as well. And the major pointer here is that for your consumers, nothing should change. If anyone is using g1.apirasia.com, for them, it should remain that way. It should not change. Nothing should be changed there. If they're using g2.apirasia, that is absolutely fine. It should be the same way. But you're going to change something in this architecture, replace something, and put something in so that everything remains same, but you get a little bit benefit on top of wherever you are, and you move towards a direction, a vision that you can eventually evolve to something more, right? That's where we are coming up with HyperMesh. Now, this HyperMesh is just another layer, but it's built using Istio. It has so many other things. We'll cover a bit of it maybe in a few of our next slides. But yes, we have HyperMesh layer. Now, that HyperMesh layer is built using Istio, and what we are trying to really replace, if you just compare, that instead of n number of different setup for applications and API gateways, why don't we combine them together in one layer? Everything comes together in one layer. From your WAF, you're still pointing to that HyperMesh IP. For each and every domain, you are pointing to that HyperMesh IP. But that HyperMesh has that much segregation of application upstreams versus API upstreams. And those of you who have already worked with Istio, I'm sure you know it's very easy to do that, right? It's very easy. So since it's very easy, we are just leveraging that easiness of doing things, and we are bringing in value. Now, what value you are looking at today, if we can go in this direction, is first of all, you are getting rid of all those different setups you had. That's maintenance overhead for you. It's gone out of the equation. You can throw it out, gone, right? And the second one is the cost of maintaining all those different infrastructures and like whatnot. You don't have to worry about them at all. It's gone out of the equation, out of the picture, and now you have only one single layer, right? Now, this is what is HyperMesh, but actually HyperMesh is way more than that. But while we are at it, we want to show you few simple things in terms of like when we started designing HyperMesh, because as you can understand, when you are onboarding the entire ecosystem of systems for a very large organization, I mean, it's not large like Google, of course, no, but it's quite large, right? And it's quite large for, I would say, a 14 people SRE team, right? When you are doing that, and at that moment of time, in this layer, you are putting everything in, you had to come up with certain very detailed integration plans. How will these integrations happen, right? What will be the folder structure? That's also a very important thing, by the way. How you're going to structure each and everything under your HyperMesh, that central source code of your HyperMesh is very important. Because eventually what you're going to do, as you can understand, see, AirAsia.com might be a responsibility of a certain team, right? Maybe homepage team, let's say. The g1.airasia.com is maybe a certain team's dependency as well. Here, these are just 3 different domains that we have shown, but there are plenty of other domains. And just consider that when all of these domains are coming with you in HyperMesh, now all of these configurations are staying in that source, huge source repository, right? So that's when you have to plan it in a way so that at some point you can onboard different dev teams and you can tell them that, you know what, this particular segment of source code is yours to manage, maintain, right? And that way you give them, it's in central place, but it's still segregated for team to team. They can change it from one single place, do work, and we don't have to worry about multiple distributed different configs here and there. And we can standardize everything from one place. So that's our value proposition in the very beginning for HyperMesh. There's many more, but before going there, let's take a look at our folder structure, how we structured it. And then I think a bit of demo, like how it's working today, a bit of local demo. I mean, it's hosted, but we are doing the host from our local and then pointing it to there. So Imran is going to take over again.
Let me share my. I'm actually going to first show you how we have actually structured the whole setup. So it's actually easier for different dev teams to sort of be bothered only about their piece of the pie and extending their configuration from only that segment. The thing is, let's say, for example, the different upstreams as of right now might be using completely different tools and technologies. We want to give them enough room and space so that their gradual migration towards Istio in their upstream ecosystem, they can actually take their own time. And different teams might actually have their different adoptions, different timeline for Istio adoption. We want to bring Istio across the board, but we cannot actually, switch over to Istio in all the different dev teams overnight. So what we started to explore is that how can we actually centralize all the configuration, and we make certain changes, but for the upstream users or the consumers or different dev teams, the disruption should be as minimal as possible. They should, at a certain point in time, the DNS record update should be, just a cutover of traffic from their old legacy ingress to this HyperMesh, and this should be as as seamless as possible. So if I actually just show you inside the service upstreams, and in this upstream folder, they will just have their different domains, and inside their domains, they will have their destination rule, service entry, and virtual service. This destination rule and service entry is just to indicate that which upstream this entry should point to. And in this virtual service, they would actually define all their configurations regarding their course policy, their traffic routing rules, and if they want to do any subset for canary deployment and things like that. But all the configuration actually should reside in this folder, and a certain dev team should only be bothered about this one specific folder. All the other structures, this plugin based feature adoption, it will come in a later slide. But just to get a chunk of the traffic routing, all the traffic that is actually relevant to your particular upstream, you just add a folder and add these configuration files. You should get the traffic to your upstream just like that. So that's on how we actually have structured the different upstream folders. And in overlays, if you have different requirements based upon different environments, you can actually just write a patch file and sort of modify your requirements based upon your different environments. So one of the primary benefits of using Istio in this setup is that not only it actually supports a front-end application and a back-end API-based application, it can also actually support your static back-end buckets as well. So as of right now, we actually have a variety of different upstream applications. It might be an app engine, it might be a VM, it might be another Kubernetes cluster. The upstream cluster might even have a service mesh, but it doesn't matter actually. We're not really bothered about what exactly lies in our upstream, but we are actually bothered about giving a seamless experience so people can just connect to this HyperMesh, and in their own pace of development, in their own timeline, they can actually they can actually adopt Istio in their upstream ecosystem. So just to give you an understanding, if I just open this is a very basic example of a front-end application that is actually loading through HyperMesh. Give it a second. This is a very basic example where it's loading a completely front-end application that has all the static contents. And if I show you another example of an application, this actually contains a backend API-based setup. So it doesn't matter how, what sort of backend you have, even if it's a group of API endpoints or this is a front-end application. We have tried this out with cloud functions, storage buckets. It actually works across the board. So that's one of the key benefits of using Istio. So it doesn't matter what type of upstreams that you have. You use the same set of abstractions to reason about different infrastructural components, different flavor of infrastructural components. So the knowledge is actually very easily transferable across different components. That's it. Munim, you want, let me share the slides again.
Yeah, yeah. Sorry, I'm gonna take over anyway. Thanks, Imran. Thanks for the demo. I mean, what Imran showed, I hope everybody understood. It's very basic. I mean, for obvious reasons, we cannot show certain other parts of it, but we just tried to give you an overview of like what we are trying to build in like, you know, like for example, we just want to create it in a way that it's extensible. From there, we want to go in so many other layers of it. Cool. Let me get back to the slides. We have a few more things to cover. Then we take it from there. Okay, so that's great. I mean, like so far what you have seen, you have understood that it's just replacing bunch of API gateways and application reverse proxies that we had. So, I mean, it's giving a benefit of consolidation and like, you know, like centralized, I would say access and everything. But what are other things that we discovered along the way when we started building this tool, right? Let us walk you through to those things very easily. So one of the major problem that we had, I'll try to. I just had a quick question for Teja. Teja, do we have like any time limit?
Yes. No worries. Please go ahead. Go ahead.
Okay, sorry, because I think like we covered so many things in one, so the content is a bit too much maybe. So yeah.
I mean, there's some people who've already dropped off, but it's okay. Go on. We're recording this, and actually the people who have had to leave, they said they'll check the recording later. So yeah, carry on, and we'll record it. And yeah, if somebody can't stay for the whole presentation, they can watch the recording.
Yeah, I think like because the timing is a bit on the.
It's okay, like, and we're still gonna be doing the Q&A session, so it's fine.
Okay, cool. Okay, I'll be quickly covering this. The problem that I wanted to discuss here is like whenever you have when we say that all of these application upstreams and API upstreams we have, how are they actually connected from the different API gateways and the, you know, the reverse proxies? Because all of these API upstreams or application upstreams, they have different subdomains, right? From our base domain, they have different subdomains. And of course, if I have to make sure that the communication from reverse proxy or different gateway layers to the upstreams has to be secure, we had to provision, you know, we had to get certificates for each of these subdomains. And since all of these different subdomains are, as I said, of course, 90% of them are in Kubernetes, but a lot of them are still in GAE, like as Imran mentioned, in Bucket, in Cloud Function. So for all of this, we had to maintain a way for like, you know, provisioning certificate. And that was mostly, we had to buy a certificate most of the time, right? And then we had to put them in all of these upstreams. With this setup, we figured out that we have a way for automating this entire thing using a self-signed cert process, where we can still have encryption in between the HyperMesh and to the upstream, as well as we can go for a very strong self-signed cert. We can have the CA install on our HyperMesh, and that way we can have a very secure communication. And the great part of it is like we can automate how the certificates will be placed in each and every upstream, right? That's one of the benefits that we saw immediately when we started thinking about it. And the other one was, this is an interesting problem because let's say we have a subdomain which is for a particular product, let's say x.airasia.com, that's being pointed from the reverse proxy in path/x, right? And when that happens, you expect in whenever you are talking from SEO perspective, whenever I'm searching for product X from AirAsia, I should be seeing airasia.com/x. But since your subdomain, which is x.airasia.com, is also public, then of course that is crawled by Google. So whenever you search, actually x.airasia.com starts popping up at the top, not the airasia.com/x, right? It's a huge problem if you see, and that's where like our SEO team were like really pissed off, like why this is happening, why we cannot fix it. With this solution as well, we saw another improvement here is that for all these upstreams that we have with proper firewall rules in place, what we can do is like we can do the NAT IP whitelisting. We have multiple NAT IPs from the cluster where HyperMesh is like running. So if we can whitelist those NAT IPs, so the only path that is allowed is from HyperMesh to those subdomains. You can never go to those subdomains and just go there and check it out. So the crawling is turned off, and also those subdomains gets, you know, even though the domains are there, it's becoming private. So that's something our InfoSec team as well as the SEO team liked together. Like, okay, this is an additional benefit that we're going to get with this architecture. Another thing, as you can see that we have WAF layer and CDN layer, we are using a paid WAF solution today from a vendor. Then we started thinking about that, why don't we build an, on top of some open source technology, why don't we build an in-house WAF that can prevent us from, let's say, why don't we just give it a try? And why don't we bring it in an extensible manner to our HyperMesh? Like it's like a plugin, you can add it, and then it's started working for everyone. The benefit would be that, again, we don't have to, right now, we pay for each and every domain which is behind WAF, which is protected by that WAF. So you see, consolidate like n number of domains that we have today, which is being protected by the WAF, you put it in the HyperMesh, and that's our built-in WAF plugin. And then you start getting the benefit of WAF, and the WAF that we have built in-house, our InfoSec team has done a rigorous testing, and so far we have seen like it can protect almost 98% of the WAF vulnerabilities that we have today. So it's quite a progress, and that's something we are exploring, that we want to bring it in, to be very honest, that WAF as a middleware in front of the, inside the HyperMesh. So just to give an idea of like, if you guys are curious, like how we are doing it, we are actually utilizing Envoy filters, and there is a particular, of course, another different WAF service altogether, which is coming together and getting piped in, right? And if we are in the, I would say, internal alpha, because it's an internal product, where in which state we are, it's an internal alpha, and we are planning to go pilot with subset of sites by mid of August. And if we can do that, you can see that we have reduced another layer. And what is the benefit of this another layer, reduction of this another layer, is that previously the communication from CDN and WAF had to be secure as well, right? That had to be encrypted. So we had to place our certificates in WAF layers as well. Now, when it comes like this, again, for CDN or for DNS or whichever, the forefront is actually the HyperMesh IP. So HyperMesh domain, right? All the domains that we have that we are going to onboard with HyperMesh. So we can just put all those certificates there, one layer of maintenance, and everything is sorted. We have one less layer, and just another third-party dependencies only on the CDN, which we don't want to get rid of, to be very honest, right? It remains there. We cannot build it on in-house. But this is something that we want to, we are exploring. We have seen quite a good success here. So I think we are going to give it a try for like a subset of our systems very soon. Another thing that we are exploring is extending how far we can extend this HyperMesh, right? One of the key requests that we have had quite a lot of time from our all of our developers and all of our different teams, that they have different API gateways, or even in the backend, the actual upstream itself, they have rate limiting implemented, and it's segregated different logical portions. Someone's rate limiting is depending on certain memory store, Redis and whatnot, failing, lots of components to take care of, right? So that's where we thought about, since the way we build this WAF component and we plugged it in, why don't we build, we use a rate limiting engine as well, and we plug it in the system using the same approach, same Envoy filter and everything. And again, this was a POC we started, and we had quite a great success. We saw that we can actually define rate limiting now by different upstream, different path-based setup. So we eventually want to extend this support to all our dev teams, and I'm sure they're going to love it. They're super excited already about it, and this is something that we are also thinking about to bring in, right? So yeah, I mean, this is so far like where HyperMesh is going. Where we are at is we showed you that we just replaced one layer of the entire journey. Now we are actually consuming more and more layers. I think the obvious question should be, we are introducing a single point of failure. Just to assure you that since we are building it as the front layer of all the systems, we have already taken that into consideration. We have thought about like how we will make it fault tolerant, having more high availability, having a different failover setup ready, and having a DR setup ready as well. So those are in the pipeline of like, plan, but we're still very young. We are just rolling it out in pilot. So yeah, we are planning to do that. The obvious part of the entire system, of course, at the beginning we said we want to bring in more control. So we want to see the dawn, and we want to bring in more monitoring and alerts. So here's the fun part. If you look at HyperMesh, when you are looking at Istio itself is, whenever it is being used as a service mesh, it's actually a service mesh of internal services. And what we built here is basically an external service mesh, right? All the different nodes that you have here are actually external services. So in our Kili dashboard, we can see which services are down, whichever external service is going down or something. Traffic is like this percentage, this many failures, this many 500. So we have that data, that's right there. But what if I want to see why a particular node is failing? That data is important as well, right? Why that particular node, and whatever the internal services are there in that particular node, how do I really look at that, and how do I really get that data to also know why that node is failing? Interestingly, we have another project ongoing. Maybe we can get another chance in some other talk where we can explain that. As part of which project, we are able to pipe in that data of different external nodes we have, whether it's an internal service mesh, whether it's using Istio or not, using a different gateway, different ingress, we don't care. We can pipe in that data, and that data is coming in a central place already. We have that big data lake set up. It's coming in. What we plan to go is that we tap on that data, because that data is coming in. We tap on that data using a Grafana dashboard, and we start setting up those alerting for all those different data bits and points that we have. We are very hopeful about it, because we have already built the data lake. We have seen the data is coming in. It's just a matter of time. Like we build those custom dashboards, and we start like setting up those alerting. So our hope is eventually that gives us the entire picture of the entire ecosystem that we own as an organization. Yeah, so that's the monitoring and alerting part of it, how we are planning it. This is just the phase 1 that's going on. The phase 2 is the harder part. As you can understand, in the phase 1, we are doing everything. We're setting it up and everything. The phase 2 is actually the onboarding part of the different dev teams, so that they can come in, they onboard, they know the different segments they own in this big, huge monorepo, and they start owning them. They start owning them in a way that they know what they're doing. So there's a lot of learning, knowledge sharing, and hand-holding part that's remaining with the SRE. Apart from that, what we are also exploring is we are trying to push people. So all of these upstream nodes that we said, external nodes, they're also, in Kubernetes, right? A lot of them are in Kubernetes. And those, a lot of people are using today GK Ingress or Nginx controller, other like few teams are even using Linkerd. So we want to standardize Istio there as well. So eventually we want to push these people to use Istio even in those, so that we have only one choice of stack everywhere. And eventually we are also exploring ideas like primary and remote setup. So so that we can see that if we have Istio in different external nodes, and how can we really plug and play this data together to get the actual connected observability from a central place, which is HyperMesh Istio, right? That's again, it's an idea phases. We're just ideating. We are seeing what we can do. There are of course certain limitations in terms of how these are implemented in Istio and all the different other tools that we are exploring, but we are getting there, and we're really hopeful about it. So yeah, that's what we wanted to really talk about to you guys today. We would definitely love to take a few questions now, if there are. So yeah, please go ahead.